So from previous discussion, we know that percentage change is new value and so it's actually not working. So we have seen that our elasticity measurement is the percentage change in quantity demanded is basically new value minus old value divided by old value times 100. This is always a generic case of how you calculate percentage change. You take the new value of the variable, from that you subtract the old value divided by old value times 100. You can do the same thing for percentage change in price. Take the ratio of that, you get the price elasticity of demand, which is always a negative number. So in case of a price elasticity of demand, we really do not pay attention to the sign of the number. What we care about is the magnitude of the number. We also talked about the idea that you can use a second formula called the midpoint formula in calculating price elasticity of demand. The basic idea behind midpoint formula is that when you go from point A to point B versus point B to point A, sometimes elasticity measurement varies, and we really don't like that. So what we do is that in the midpoint formula, rather than just having the old value in the denominator, we take a weighted average of the new and the old value and divided that by, and use that as the denominator. So the basic difference between our standard measurement of elasticity and the midpoint formula is that in the midpoint formula, your denominator is a weighted average of the old value and the new value. Other than that, the interpretation is more or less the same. We also talked about the interpretation of the number that we can just calculate by using this method. So after ignoring the sign, we look at the actual dimension of the number. If the number is greater than 1, we call our demand to be elastic. If that number is less than 1, we call our demand to be inelastic. And if for a very rare situation, the number turns out to be equal to exactly 1, we call our demand to be unit elastic. So three ways, three interpretations of three different numbers for price elasticity of demand. We also spend a little bit of time trying to understand what does these numbers really tell us. What do we mean by an elastic demand curve? What do we mean by an inelastic demand curve? We said that if you compare between D1 and D2, D1 is a more elastic demand curve. It is a flatter demand curve where for the same given price change from $4 to $3.70, the change in quantity demanded under D1 is larger. When you go from A to B, the change in quantity demanded is larger. So that was the interpretation of demand 1 being a more elastic demand curve, demand 1 being a flatter demand curve. Compared to D1, D2 is steeper. When you move from A to C rather than from A to B, under D2, you notice that the change in quantity demanded under D2 is smaller than change in quantity demanded under D1. So D2 is steeper than D1 and less elastic than D1. So D2 is inelastic, D1 is elastic demand. You can also do the calculations. You will see that the price elasticity of demand under D1 is greater than 1 and price elasticity of demand under D2 is less than 1. So there are various ways of interpreting the price elasticity of demand number. They are directly connected with the shape of our demand curve. Okay. So we also looked at, we actually calculated this particular example. Did we do this? I think we did that. Did this one, right? So we looked at these two demand curves, and for a given change in the price, we calculated the price elasticity of demand associated with D1 and D2. We also showed that when you calculate the price elasticity of demand under the traditional method, which is the denominator is just the old value, or the midpoint formula where the denominator is a weighted average of the new and the old value, really does not change the interpretation of the price elasticity of demand, meaning that elastic demand will always be elastic, and elastic demand will always be inelastic. What the midpoint formula does is that it gives you a more precise measurement of price elasticity of demand. And I mentioned before, I'm going to mention it one more time, that unless, excuse me, I apologize. Yes. I need to take this call. I apologize for this. My children are at a school, and sometimes I get calls from the school, and I need to attend that. I apologize. Okay. So we could calculate the price elasticity of demand under different demand curves with if we are given the price information and if we are given the quantity information, just like it is given in this case. Okay, we also talked a little bit about how the slope and the elasticity concepts are connected. They are related, but they are not the same thing. The slope of a demand curve can tell you a little bit about whether the demand curve is flatter or steeper, right? So if the slope is small, we know that our demand curve is flatter. If the slope is large, our demand curve is steeper. Are we all clear on what the slope of a demand curve is? Does anyone need a clarification as how you can calculate the slope of a line or a graph? Okay, good. We're going to look at so we can summarize basically the various shape of the demand curve by the use of this very useful table. So let's go over each of them. For example, when your demand curve is greater than 1, we call it elastic demand curve, and you can see clearly that 8% decline in price causes more than 8% increase in quantity demanded. So when the increase in quantity demanded is greater than increase in price, you can see clearly that your elasticity of demand is going to be greater than 1. So percentage change in quantity demanded divided by percentage change in price is your price elasticity of demand. So anytime the change in the numerator is larger than change in the denominator, this will be greater than 1. And anytime the change in the numerator is smaller than change in the denominator, this will be smaller than 1 and vice versa. So for an elastic demand curve, we will have for a given 8% change in price, your quantity demanded increases by 20%, which is more than 8. If it is inelastic, then an 8% cut in price causes less than 8%. Let's say in this case 5% change in quantity demanded. So that's inelastic. You could have a rare situation where given percentage change in quantity price like 8% causes an exact 8% change in quantity demanded, which means that the denominator and the numerator in our elasticity calculation are identical, which means that our demand is unit elastic. There are two other unusual shape of the demand curve. They really don't have any empirical significance, but sometimes we want to test our students to see whether they understand what does these two other extreme shape of demand curve means. One of them is called a horizontal demand curve. In 2 chapters from now, you are going to see this. Either before exam number 2 or immediately after exam number 2. So the demand curve sometimes could be horizontal, meaning that for any changes in the price, demand is 0. Do we all see that? In this case, the demand curve is only defined for price level 4. If price level goes up more than $4, or if price level goes down below $4, your demand curve is not defined. When we have a demand curve like that, we call it a horizontal demand curve. Now, for a given, so in this case, the elasticity of demand is actually infinite. Why? Because are we all clear on why this, in this case, the price elasticity of demand is infinity? How, any thought on this? Well, this is not that important to really understand why the this is based on some mathematical, abstract mathematical notion. It's not that important. What is important is that if your demand curve is horizontal, we call it a perfectly elastic demand curve, and we assume that the elasticity of demand is actually infinite. Infinite is something that cannot be really measured. We actually have a concept about what infinity means. But that's okay. But another, again, not that important for empirical research, but probably important from a conceptual perspective, is when your demand curve is vertical. When your demand curve is vertical, notice that for any given change in price, your quantity demanded does not really change. We all see that. So, for any given change in price, denominator is a positive number or negative number, doesn't really matter. Your change in quantity demanded is 0. It's always 0. So 0 divided by something is always 0, right? So if this is 0 in this particular example, our elasticity of demand is 0. It's called a perfectly inelastic demand curve. Or in simple words, it's called a vertical demand curve. Demand curve is vertical. Elasticity of demand is equal to 0. This is called perfectly inelastic. These are all similar. These are all talking about the same thing. This has some, sort of conceptual intuition. So, can we think about goods for which the demand could be really perfectly inelastic, or something close to that? Very good. So, you can imagine that there are a lot of goods in our daily, everyday life for which we really don't care about the price. It would be a life-saving medication for which the demand is probably very similar to this. In a minute, we are going to see that this gives our firms a big opportunity to make profit. Because when they know that regardless of what price they will charge, our buyers are going to buy the same quantity, meaning that our buyers are completely irresponsive to changes in price. These are the goods for which firms can make a lot of profit. And the profit will come from the large amount of revenue that they can generate. Okay, so more on that later. So, and we're going to talk about that today and right now. So before we move on to that, I want to spend a little bit of time just to give you a sort of like an empirical sense for what these numbers, the price elasticity of demand numbers, could mean for us. Okay, so the question that you're looking at in the slide. So let's think about the question, right? When we calculate the demand for gasoline, people argue that the demand for gasoline is inelastic. Meaning that whenever price of gasoline changes, demand for quantity demanded for gasoline does not really change that much. Do you think that this is true? Can we argue that the demand curve for gasoline can we argue that the demand curve for gasoline looks like this or that or this? So let's call this D1, let's call this D2, and let's call this D3. So which demand curve do you think is really can represent the demand curve for the gasoline? D1, D2, or D3?
D1.
Why?
It's not perfectly elastic.
Right, but so that's a good answer, because the idea of elasticity is always a relative concept, right? So if you are given only these three options, notice that two of them are like extreme cases, right? D2 is when quantity demanded does not respond to price at all, which is obviously not true, because whenever gasoline price changes, we do respond to that by carpooling or by not driving as much as we do regularly. There are a lot of ways we respond to changes in gasoline price. D3 cannot be true either. If your your demand for gasoline cannot be perfectly elastic. So between these three options, demand for gasoline is probably D1. If I had another graph which looks like that, let's call it D4. One could argue that D4 probably is a better representation of the demand for gasoline because it is more inelastic, right? So we can therefore say that our demand curve for certain product are going to be more elastic than others. Demand curve for some product are going to be less elastic than others. Okay. What is the implication of the demand curve for gasoline to be inelastic? Why are we interested in learning about whether our demand curve is elastic or inelastic? Let's look at these two examples. Okay? Imagine that the demand curve for gasoline is indeed a vertical line, and imagine that there is a leftward shift of the supply curve for gasoline for global turbulence in the oil market, war in the Middle East, or whatever. For some reason, there is a decline in the supply of gasoline in the market, and the price goes up from P1 to P2. Okay. As opposed to the first case, in the second one, your demand curve is kind of downward sloping. It is probably inelastic, but not as much as our first demand curve. And when there is a leftward shift of the supply curve, for the same effect as the left one, your price goes up from P1 to P2. We want to now ask a very critical question, and I want you guys to think before you answer the question. Where do you think the change in price is greater? Is the movement from price P1 to P2 greater than the movement of price from P1 to P2, or the other way around? Are we all clear on the question? In order to avoid confusion, because I see a lot of confused face, let's just call these P3 and P4. Okay? So we have P1, P2, P3, P4. In both cases, prices are going up because supply is going down. We know that it's going to cause our price to go up. Now I want to understand the difference between price in the first price change in the first case and price change in the second case. Can we compare these numbers? What do you think? No, it won't be. Why? Let's start with your answer first. I should have asked for your explanation first. Why do you think the price change is going to be the same?
I just figured it depended on the product that you're selling. So if you're selling a product, then see a difference. But if you're like if this is two different products, then you get the same price change, but whether it's inelastic or elastic.
Okay.
Like the angle of the line.
Okay, point well taken. Do these two graphs remind you of something? Does this exercise remind you of anything that we have done before? In chapter 6, we looked at how taxes really shift the supply curve, and depending on the shape of the demand curve, the seller or the buyer pays a larger burden of the tax. Do you remember that? There is no tax here, right? There is no tax here. But there is a similar kind of leftward shift of the demand supply curve. So this could be similar to a tax imposed on the seller. Do you all remember that? So what was the interpretation of a tax imposed on the seller? So when the tax is imposed on the seller, if the demand curve is vertical, who bears the tax? The buyer pays the full amount of tax, which means that the entire shift of the supply curve as a result of whatever, in your previous chapter this was tax, in this case this is just a market disruption, is being borne by our consumer. Which means that in this case, the size of the price rise is going to be much larger than the size of the price rise in this case. In this case, part of the shift, part of the changes in the supply is going to be sort of borne by our suppliers. Make sense? Okay, good. Let's now spend some time going over some questions. I don't want this chapter to be an abstract chapter, because if you try to think of this from an abstract point of view, this is not a fun chapter to really study. This is a quite difficult chapter. So let's look at some questions and try to see whether whether our direction of thought in terms of these materials are in the right direction. So let's start with this question. So elasticity is a measure that shows definitional question. What would be the answer? These are definitional questions, but again, these are also philosophical questions, because it is asking you about your knowledge about the foundations of what elasticity really means. So which one is the correct answer? The correct answer is D, because your elasticity is basically measuring how supply and demand response to changes in market conditions. That's actually a very general idea about what elasticity is, right? What we have done so far is that we have shown how quantity demanded changes whenever price changes. But the question is, where is that price coming from? That price is coming from market, right? So basically, by looking at price elasticity of demand, we are trying to understand how demand responds to market conditions. When we will look at the price elasticity of supply, that will also look at how supply responds to changes in market conditions. Okay, so which of the demand curve is more elastic? The answer is D1. I'm going to skip that. If the demand curve is perfectly elastic, what is the impact of an increase in price? While you are looking at this question, it is highly recommended that you draw these graphs. Because the more graphs you draw, the better will be your understanding. So we are talking about a perfectly elastic demand curve. A perfectly elastic demand curve basically looks like that. So in case of a perfectly elastic demand curve, whenever there is a change in price, let's say from P1 to P2 or to P3, really doesn't really matter. Whether prices are going down or going up, what is happening to quantity demanded? It's 0. It's not unchanged. It's 0, right? It's not measured. Are we all clear on that? Okay? So, in this case, when there is an increase in price, the decrease in quantity demanded is 0, right? There is no measurement. There's no change. Okay. Yeah. Okay. So we have looked at the definition of price elasticity of demand. We have looked at how price elasticity of demand is calculated. We have looked at the interpretation of the price elasticity of demand in terms of what do you mean by elastic demand, what do you mean by inelastic demand. The next topic is to figure out what factors really determine these elasticity concepts. Because not all markets have same kind of price elasticity of demand. Not all goods have the same price elasticity of demand. So the question is, what are the issues that really govern the magnitude of this price elasticity of demand? As we are going to see that these are all quite intuitive factors that really change or affect your price elasticity of demand. The first one is obvious. The availability of close substitutes really affect your price elasticity of demand. So we can go back to the insulin example, and we can argue that insulin probably doesn't have a close substitute. Why? Because it's a life-saving device, medication, and the medication, there are no close substitutes of insulin. So for a good that does not have any close substitute, the demand is going to be very price inelastic. Meaning that our consumers really don't have any option to buy anything else when price changes. So when our consumers don't have any option of buying anything else when price changes, quantity demanded doesn't really change. Hence our demand curve is going to be price inelastic if the good does not have any close substitutes. On the other hand, if there are a lot of close substitutes for the good in question, our demand is going to be very, very price elastic. The classic example, Coke and Pepsi, right? Coke and Pepsi are probably the best example of perfect substitutes, because anytime the price of one of them changes, the demand for one of the other one goes down dramatically. Okay? The second one is, again, quite intuitive, but we need to really spend a little of time try to understand that before we can make the conclusion. The issue of time is kind of important for price elasticity of demand. Why? Well, let's think about the stuff that we buy on a regular basis. Think about iPhone, right? The first ever smartphone with a lot of touch screen options, with a lot of really good options. When it came out, there was basically no substitute for that phone, right? And during those early couple of years, Apple made billions of dollars, right? So you can argue that when the first generations of iPhones came about, the demand for smartphone was very, very inelastic. I'm not talking about for the entire market, right? I'm talking about people who were buying those iPhones. Because this distinction is going to be very important in a minute. So can we argue that when at the beginning of a marketing process, a good, if it is well received by the customers, could have a very inelastic demand, and over time, as competition arises, you have competitors like Samsung and Motorola and so many different companies trying to provide the market with some imperfect substitutes, and the elasticity of demand for iPhones will slowly go down, right? So over time, the good for which the elasticity of demand was very low, meaning that the demand was inelastic, could slowly become price elastic. Make sense? Okay, so the gasoline example is not a good example. The one that is that is being given here is not a good example because let's put it this way: gasoline really doesn't have good substitutes. You can think about these hybrid cars, the electric cars; they are not good substitutes for gasoline. The only thing that what would be a good substitute for gasoline? Why is electric car not a good substitute of a car that is run on gasoline? Sorry?
Does it go as far?
Well, it does. I just saw a car from Colorado, and the car is an electric car. The guy actually drove from Colorado to here. This is huge distance, right?
Still has to have a fuel. Still has to have a fuel to generate electricity.
Okay, so details important. So there are some technological differences between those two. But what is the bottom line? Why is electric car not a good substitute for a gasoline-driven car?
Is it because you still have to pay a bunch of money for electricity?
Yeah, it's very expensive. It is very expensive. So they are not even in the same customer category. So if I am a person who wants to buy a sedan and I am looking for a Toyota Tercel, I'm really not interested in buying a electricity-driven car because I don't have the money. If I had the money, I probably would be trying to buy a larger car. There is a problem in this market, right? So, but what will happen and what already has been happening is that over time the price of these electricity cars are going down. That's always happens with technology. So over time we respond to these changes in the market conditions quite differently. So initially, even if the demand is very inelastic, over time, as a result of good substitutes, as a result of our adjustment towards these market conditions, our demand slowly becomes more and more elastic. So you can argue that if you start with a really vertical demand curve, over time the demand curve is going to become flatter and flatter. Make sense? Okay. Now the next one. In the last discussion, we were trying to distinguish between whether iPhone. How do you look at the demand for iPhone? iPhone is a luxury good by every measurement. Right? It's very expensive. Not everyone really can afford an iPhone, or not everyone really has a budget for iPhone. When you think about a good such as iPhone and define that to be a luxury good, the demand for a luxury good could be very much different from the demand for a necessity good or a necessary good. You can argue that the demand for luxury good is very elastic, meaning that unless you get a really good deal on a luxury cruise, you are not going to take that. On the other hand, if there is like a 2-cent discount on milk, you're going to go to the Walmart and buy a bunch of them. Right? This is how we respond. This is how our demand for luxury goods and our demand for necessary goods are so different. Let me go back and correct one statement. So if you are looking at milk and there is a price discount on milk, how would your demand change? You just made a statement that if you are talking about a luxury good, luxury car, luxury cruise ride, a discount really helps because whenever price goes down, people respond dramatically to these price changes because they are luxury good. Previously they were very expensive. Now you are thinking about really buying them. But what about milk, which is a necessary good by every measurement? If the price of milk goes down, how much do you respond to the change in price of milk?
Still just buy as much milk as I need. really affected?
Right, precisely, right? I mean, milk is something that you buy on a regular basis. Milk is something that you cannot store to begin with. There's a problem with milk, right? So, if the price of milk really goes down, do you really change your demand for milk? The answer is probably no. Because you are already buying the amount of milk that you need, right? That's why it's called necessary good. So we could therefore argue that the demand for luxury goods are very price elastic and the demand for necessary goods are price inelastic. Okay, the next one is kinda, sort of confusing. So please stay with me. Okay, we have really not talked about how we define a market. This is a fairly new concept. So far, our concept about our discussion about market was rather hazy in the sense that we were only talking about market is a place where buyer and seller meet and this and that. But there are other implications of what a market is, right? A market could be like a market for chicken and it could be a market for meat. What's the basic difference between these two? What's the basic difference between market for meat and market for chicken? They are both markets. Anyone?
Meat includes chicken, pork.
Everything else. So a market for meat is a much larger market than market for chicken. Are we all clear on that? And the size of the market and how you define a market to be has very important implications for demand. Okay, so the example that is being given is kind of I like this one. So let's look at the example. So it is true that for a lot of people there is no good substitute for jeans. So you can argue that the demand for jeans is very inelastic. Remember last time we talked about that Levi's hardly gives any kind of discount. There is hardly any discount on jeans in USA. Because people already buy a lot of them, there is no reason to really cut price to attract new customers. One could argue that if you are focusing on a particular brand like Levi's, the demand for Levi's is probably more price elastic than demand for jeans altogether. Why? Let me repeat my question again. Why is the demand for jeans why is the demand for jeans more price inelastic than demand for Levi's? Are we all clear on that? Because you have good substitute for Levi's, there are other brands. But when you think about the definition of jeans in general, the demand is probably more inelastic. So the same example is for the market for meat and market for chicken, right? So one could argue that the demand for meat is very price inelastic. Why? Because there are with the exception of a very small fraction of the population, almost all of us eat a lot of meat. Various kinds, but meat altogether, right? But then again, the demand for chicken could be more price elastic, right? Because anytime there is a cut in the price of chicken, a lot of people will come and switch from beef and eat chicken or vice versa, right? So the question that we want to conclude, and please write it down because the slide does not really make that conclusion. The smaller the market, the less elastic, the more elastic the demand is. The smaller the definition of the market, the more elastic the demand is. The larger the definition of the market, the less elastic the demand is. More, small. Less, big. The last one is also quite intuitive. We talked about this in the context of a salt in the last class. We say that salt is a necessary good by every measurement. But how many times? But what was the last time we looked at the price of salt? Probably never. So if there is a change in price of salt, probably there is basically no change in demand for salt. Why? Because salt constitutes a very small fraction of our budget. When something is cheap, we really don't pay attention to the price. As a result, we automatically become price insensitive to those goods. So if a good has a very small market share or has a very small budgetary share, the demand for that good is price inelastic. If a good has a very large budgetary share, like a luxury good, the demand for that good will be very price elastic. Okay. The table that you are looking at talks about a bunch of different measurements of elasticity. When you are reviewing this chapter, please take a look at some numbers. These are actual numbers calculated based on actual data. They are fascinating. I'm going to skip this market connection. This is a very good example of how people use elasticity measurement in actual market research. Please read that on your own. We have 5 minutes. In that 5 minutes, I do not want to start a new topic. What I'm going to do, I'm going to go over some questions. Please look at the questions. So which one is the which one is the correct answer? I did not talk about this question, so I want your opinion on this. How many of you think that A is the correct answer? Not that many. That's interesting. So what do you think? So those of you who think that A is the correct answer, you are right. But the question is, why is the passage of time, share of the good in the consumer's budget, and the definition of market not important? Sorry? A and D? Well, all of them are connected, right? So you can think that with the passage of time, the availability of a substitute really increases. The share of the good in the consumer's budget, you are talking about goods that are really cheap, right? Cheap goods could have actually good substitutes, by the way. But the basic motivation for finding substitute in the market are goods which are really expensive. These are the goods for which we really get a lot of substitutes. So if you look at these answers, you would realize that A really captures most of what is contained in B, C, and D. So A could be the correct answer. Let's skip this one. And we are out of time. We are not out of time, but I'll let you guys go earlier. Okay?